Now, we have just finished talking about the epithelium. The other three tissues are connective tissue, the which is the biggest group, the muscle tissue, and the neural tissue. Now, you can think of connective tissue is different from the epithelium. Is that in the epithelium, the cells sort of like attach to each other like this, okay, via intercellular, right? But connective tissue, the cell do not necessarily have to form a barrier, a community, okay? That's the key word. Epithelium forms community, okay? So epithelium forms this community of cell, okay? And they are linked together, for example. In connective tissue, they don't have to be like that. I mean, you can have a cell here, you can have cell here, they have cells here, and they have cells there. But what they do is they put out a lot of matrix. You see that these are matrix, and the major matrix that you see, they call these extracellular matrix or collagen. It's a key matrix, collagen. You can see that collagen matrix. All right, so a little bit of function about connective tissue. They sort of like, in terms of bone, so they provide the framework. Adipose tissues fill up the space. Adipose store fat. The three specialized connective tissue, that's an important one. Three specialized connective tissue are the radio station, BBC, British Broadcasting System. The BBC is the way for you to remember. These are your bone, blood, and cartilage. Okay, that's the specialized connective tissue. Part of the blood work, you can see that, carry oxygens and nutrients, blood cells. In the blood, there are white blood cells play important in infection, and to some extent, if you have a damage in the blood vessel, they have helped you prepare that through the coagulation. The matrix is an important part of the connective tissue, depends on these matrix. If the matrix is not organized, right? So we call these, it's loose, but in the cases, in some connective tissue, they're highly organized. Okay? By organized, it goes like this. The highly organized one, and there may be some cells there, maybe some cells, and these are your two important ones, tendon and ligament. What's the difference again? Tendon would be the one that connect, so connective tissue between muscle and bone, whereas ligament is between bone and bone. And they would have highly connected arrangements of these matrix. And again, they're avascular. In this case right here, so if you have a most of the connective tissue is vasculature, but in this case here they're avascular, so that if you twist them or you damage them, it takes a long time to heal. So that will mean that very degree of vascularity. And they usually have cells that divide. Okay? Again, in terms of epithelium, the only layer that has cells that dividing is the stratum basal. I don't know how many times I have to tell you that. There's the stratum basal. It has the cells that's dividing. Good. All right. So connective tissue. Here's some exam question. Establish structural frameworks for the body. What do you think that is? Someone just yell out for me. Framework, bone, transporting fluid, dissolved material, blood, protected the delicate organs like bone, for example, Stored energy reserve, triglyceride, key there. That will be adipose. Defending the body, invading the microorganism. That again, that's the blood. Okay. There are certainly many cells within the connective tissue, but the three one that is very important are the fibroblasts. These are the cells that lay down the collagens, the fibers. Yeah, that's an important one. Macrophage, important for ingesting phagocytosis. The difference between this one versus DC, dendritic cells of the skin, this is resident. This one stay put, and this the one that is activating the immune system. Remember I told you earlier, resident, they stay, whereas macrophage is moving around. Mast cells, they're important. They're very similar to this cell. The mast cell is very similar to this cell in the blood called basophil. And basophil and mast cell have histamine and heparin. And what histamine is a vasodilator. Okay, so this causes your blood vessel to dilate. Okay. Whereas heparin is prevent your blood from coagulating. So sometimes when they collect your blood, they put it in a bag they call heparinize it, which means that you don't want your blood to coagulate, stick and congeal. In a lot of people, when they get allergic reaction, for example, the basophil or the mast cells usually in the skin, but the basophil will release histamine and the blood vessel will dilate, for example. The face might look red, but you have too much vasodilation, your blood pressure will drop. So we call that hypovolumetric shock. We call that. Okay. But three important cells are fibroblasts. That's the one that produces a lot of collagen, right? Fiber, collagen, macrophage, and basophil. All right. Connective tissue typically divided into tissue proper or specialized. Now you know what the specialized are, the BBC. Adipose or reticular or dense connective tissues like the dense connective tissue or tendon and cartilage. Loose is areolar and elastic connective tissue because they have the elastin. Okay, elastin that give it. Elastin that gives it the flexibility, right? So some cartilage might have elastin, so we call that elastic cartilage, like the pinna of the ear, for example. Here's our adipose tissue. You see that a lot in the histologies in the blood. These are loose areolar connective tissue, connective tissue, usually surrounding muscle. Okay, and they look like spider web. That's what I will probably use to. They look like spider web. You have that white area, usually around muscle fibers. And if you do a lot of, dissecting the muscle and you want to see the fiber, you have to remove these loose areolar connective tissue. Okay, let's put that loose areolar connective tissue. Okay. Loose areolar or other loose connective tissues are fat. The dense one we already talked about already, which is your tendon, that's your muscle to bone, whereas ligament is bone to bone. Other cells that you see, that the three important ones is fibroblasts, macrophage, and mast cells. Don't worry about too much about that. These cells, they're small, like neutrophil. In the skin, you might see melanocyte. You see that. Lymphocyte is oftentimes you find in the blood. Adipocyte is fast. This is an important one, particularly in the skin. We call that mesenchymal. These are really our stem cells. Okay? So these are stem cells. And these are the one that really dividing a lot. So now you know the theme is I kind of focus on the cell that is dividing. Mesenchymal stem cells, one of those cells that divides rapidly. Here we give you more descriptions of these cells. Focus on the mast cell is important one. I talk about melanocyte. We talk about adipocyte, fibroblast. Okay, that's the one that produces collagen. Collagen. Okay. All right. Uh, so the components of these tissue fiber that you see, right? What are they? They're typically collagenous fibers. Typically called that collagen, composed of collagen, for example, right? And it holds things together. Again, different between tendons and ligament, muscle to bone, ligament is bone to bone. Um, the cartilage, good one to know is the cartilage. Cartilage are chondrocyte, okay? Cartilage are composed of chondrocyte. And um, there are three different types of cartilages. Um, there's, sorry, um, they're hyaline cartilage, they're fibro, and there is the elastic cartilage. So then you guys need to know an example of these. Okay. Usually at the end of long bone, you have a long long bone like this. Okay. At this end and this end, there's cartilage, and that's your hyaline cartilage. Fibrocartilage is the strongest one. This is the one that is the strongest. And you see them at the intervertebral disc, so between the two vertebrae, you will see these. And at the pubis symphysis, which I showed you, at the pubis symphysis, between the two um, pubic bone. The elastic cartilage is the one that gives you elasticity. The vocal cord, like the epiglottis, is an example that is elastic. Also, the pinna of the ear. We have your elastic type. Elastic fibers are important for that. Key things about the reticular fiber is this: they form. The key word here is a network. It's a network. They form a mesh, if you will, or a mesh. So you get things like this. So if you ever see an area where people do a lot of, they pour cement, what they do is they take an area, let's say if you want to have an area, you're going to pour the cement, right? You want to put in this mesh first. And this mesh allows, and when you put concrete or cement, it binds them together, for example. So those we call those reticular fibers. So they call it supported network. And in, like organs like the spleens, that's a good example. The spleen, that will have reticular fiber, spleen, thymus, that kind of thing. They have that reticular fibers, which is basically this network. Okay. All right. So just going on a little bit more, it talks about uh, different types of collagen fibers. You can see here forms as tendon, ligament, where you know what those are. Reticular fibers forms as what we consider the parenchyma. Okay. And the sheets of the organ, what kind of organ? Again, thymus and spleen. Liver has it too. Yeah, you can see that forms as a network. Thank you, Miriam. Elastic ligament of vertebrae, um, elastic cartilage. Here's what the most cell that you can see, and the cell that is moving, more stem cells, mesenchymal cell. All these as collagen fibers. You can see that collagen fiber. You can see there. Mast cell has two important secretion products. Secretory products are histamine, which is a vasodilator, and heparin, which is anticoagulant, prevent blood from coagulating. Lymphocyte play an important role in the immune system. Adipocyte for fat, blood vessel carry oxygens and nutrients. Plasma cells important is similar to B cells. Okay, B cells. Uh, and these are all reticular fiber. Okay, all right. The loose one, areolar, we saw that loose areolar connective tissue, adipose, and reticular that you saw. Here's your loose areolar. You see how that's loose areolar. I would say that spider-like web, that's key there, important. And they're usually surrounding muscle. Okay. Adipose tissue, also loose, that's fat. You can find them everywhere. In the lab, you might see them as part of the vagina slide. You might see them in the thyroid. They're everywhere. Okay. Adipose, I'm not going to talk about too much about this, but typically white fat is for energy. If you eat too much carbohydrate, you're going to store it as white fat. Now, brown fat is to generate heat. So in baby, for example, because their heating system is not working too much, you will see a lot of brown fat. And particularly also hibernating animal. Okay, so that's the extent I'm going to talk about this. Like hibernating animal, like bears and squirrel that sleep through the winter, they will have a lot of brown fat. So, okay, so hibernating animal. And again, the brown fat is important for generate heat, to generate heat, whereas this is for the energy. In fact, it's a similar thing. It's a cell that breaks down ATP, but instead of break down the ATP causes muscle contraction. In this case, and you need muscle contraction to generate the heat, by the way, most part. That's what the shivering come from. But in the case, yeah, that's how you do it. You muscle contraction, but in this case, what they do is instead of using the ATP to cause the muscle contraction, they generate heat directly. So brown fat, heat, white fat, energy, like into acetyl-CoA, for example, part of the um, um, cellular respiration. That's what I mean. This is your cellular respiration to generate ATP. All right, so reticular tissue, thymus, lymph nodes, spleen, liver. Good to know, right? Thank you, Miriam, for that. Dense connective tissue, so they're kind of dense like this. They're not like loose, like like that. The dense one you can see here is tendon. You already saw that. What tendon different from ligament? This is basically bone to bone, where it's muscle to bone. Aponeurosis is really you have up here. We call it the epicranial aponeurosis. It's really is an area that attaches muscle to muscle. Okay, so it's really it's muscle attachment. That's what aponeurosis is. Okay, dense irregular. So that's dense regular, uh, dense irregular. Don't worry about this. You can see them next time we're going to see them. They're usually surrounding the bones. So we call that periosteum. Elastic, okay, cartilage in this page, but here this would not be elastic cartilage. This is considered fibrocartilage. Okay? This was more elastic because of elastin. Reticular, again, note the areas, spleen, liver, and thymus, dense again, tendons and ligament. That's the important one. Elastic cartilage, usually your blood vessel, an artery to expand, right? The recoil, expand, recoil. It has to have elastic cartilage, right? Sorry, elastic tissue. But in this case, smooth muscle. Your lung, right? Your lung expand, recoil, expand, recoil. It also have elastic connective tissue. And the heart, expand, recoil, contraction, expand, that kind of thing. All right. Specialized connective tissue, I told you already, which is BBC, blood, bone, and cartilage, blood. Here's your typical blood, has your white blood cell. Here, white blood cell. The reason they're not white is because they've been stained. But if you take them out, they would be white. Right? The most cell that you see in the blood are here. These are your reticular or your red blood cell. Red blood cell, okay. Also known as RBC, basically, or reticular site. So don't forget that blood has red blood cell, has white blood cell, and platelet, right? So don't just associate red blood cell or blood, just red blood cell. No, the red blood cell has platelet, thrombocyte, has your white blood cell, lymphocyte, monocyte, that kind of thing, and red blood cell. And they play an important role in defense immune system. Okay. Here's your red blood cell. It looks like they carry oxygens, also known as erythrocyte. Okay. Here's our different type of white blood cell. I'm not going to mention to you more than that, other than if you're going to go on to study in 302, the most abundant is this one, neutrophil, which has about 60% of your 100. If you count 100 white percent, neutrophil is the most abundant. That one. Lymphocyte, which is these right here, constitute about 20%. The monocyte has about 3 to 5%. And the eosinophil, this one right here, has 1 to 3%. And the least amount of cell is this one right here, called the basophil, which has less than 1%. They're really not around. So I always ask my student to arrange them from the most white blood cell to the least, right? So what you do is you remember these. Never let monkey eat banana. Okay, so that's your neutrophil, that's your lymphocyte. You see, that's your neutrophil for never, that's your lymphocyte, that's your monocyte, that's your eosinophil, and that's your basophil. Okay, that's how, remember this, then you know your order from the most abundant to the least abundant. Of that, platelet is not white blood cell, it has its own cell. It's also known as thrombocyte. Thrombocyte. There might be a condition to call it thrombocytopenia, that means low number. Thrombolytic means the break of the thrombocyte. So TTP, called thrombolytic thrombocytopenia purpura, is a condition that oftentimes people have low platelet number that can lead to bruising. So they call that TTP. All right, lymph is what flows into the lymphatic system, and it's kind of like blood flow in the cardiovascular system. Alrighty, the cartilage composed of the chondrocyte, here, chondrocyte that stays in the lacunae, chondrocyte. And then let's do and there's 3 types of cartilage we see here. The most abundant is this one, key there, most abundant hyaline. The strongest, tough, is the fibrocartilage, the one that gives flexibility is the elastic cartilage. You can see here different types of cartilage. At the ends of long bone or any bone, you have the hyaline cartilage. The elastic cartilage has give you elasticity. Fibrocartilage, two areas that you see fibrocartilage are the pubic symphysis, pubic symphysis, that's the two pubic bone fuse, and the in between vertebra, okay, intervertebra, or called the intervertebral disc. It's a little cushion there between the two vertebrae. Here's a hyaline cartilage, and the lift they stays in these area known as the chondrous. These areas known as lacunae. They're two chondrocytes that you see there. Elastic, the pinna, the ears, or the epiglottis. You see here, and then you specialize connective tissue, bone, and we're going to see bone in more extensively. But another important functions of bone is that if I ask you what is the functional units of bone, and that is an osteon. Okay, is a functional unit of bone. Right, and then typically, if histologically, this is what an osteon look like. An osteon. You can see that, and we can study more of this next time we're talking about the skeletal system. Let's do 5 minutes with the muscle, and then we can save neural tissue next time. Muscle, major functions of the muscle is basically to contract. There are three kinds. There is skeletal muscle, attaches to the skeleton, smooth muscle, which is found in most visceral organ, and cardiac is around the heart. Which one of these muscles that can divide? Anybody? Kalima? Which one of these muscles can divide? Important question to know, right? Does anybody? No? Raise your hand. Gayan?
The smooth muscle. The smooth muscle.
Good. Yeah, very important to know that one, right? This is the only one that it can divide. So remember, I gave you an example like the uterus. The females carrying a baby, the uterus get really big. Right? The skeletal muscle, when you work out, get big, but not it can't divide. The way that it get big is because the individual muscle will get bigger. So instead of look like this, the muscle will look like this. Okay, so we call that hypertrophy. Whereas here, you're getting more cells that can divide. Okay. Also, the heart can only hypertrophy, right? So if you have, because you have a blockage in the coronary artery and that cell is dead, you can't not make it more. So essentially is that you have to have a bypass or something like that because you can't get more cardiac muscle. So good. That's the other important thing. You can say that this one has striation, which means these patterns of dark, light, dark, light. This one has striation, dark, light, dark, light. This one is non-striated, if you will. Okay. Let me go back. You can see here. All right. So this will be our last slide then, and then we can say the nervous tissue. So your exam will be up to this point. Okay, which will show you histologically difference between three different muscles. And what is the muscle function is to contract. This would be your skeletal muscle. It has, if you zoom in, is this patterns of dark light, we call striation. And typically, because these inside this, there's a myofibril. Myofibril. These are actin and myosin, and they're highly organized. They're organs, so they're so organized. There's like here's your myosin, actin, myosin, actin, myosin, actin. Okay, they're highly organized. That's why you get this pattern that looks like striation. See, basically, if you stain this area only have actin, like the thin one is actin, the thick one is the myosin. And this is your actin. Because the actin is the area that doesn't have a lot of protein. That's why it's lighter. This area here will be darker. So that's why I give you that striation. The nucleus is pushed to the side. This is the only one we call it voluntary. That means you can tell it when to contract, voluntary. Whereas these two is involuntary. You cannot tell the heart when to contract. Certainly, definitely not smooth muscle. Um, Cardiac muscle have striation, you can see it, but they also branch. That's the key, and they have this intercalating disc, so it allows this cell to talk to this cell. Intercalating disc. The nucleus tends to be more center as opposed to the nucleus on the side. And smooth muscle is sort of like kind of flat, like this. And sometimes they can work together as one unit, or they can work by itself, multi-unit smooth muscle. All right, so this is sufficient regarding muscle tissue. Are there any question then? Any question? I'm going to turn off the